The analog signal is continuously changing over time and theoretically has infinite values. The digital signal, on the other hand, is a signal that takes only discrete values expressed by specific numbers, for example, 1, 3, 7, 5, 8, 4, etc. The analog signal is a continuous signal that can take on any value within a certain range over time. It is represented as a continuous waveform, and theoretically, it can have an infinite number of values since it can be measured at any point in time. In contrast, the digital signal is a discrete signal that takes only specific values expressed by numbers. These values are often represented in binary form, zeros and ones, in digital systems. In practical terms, a digital signal is a sampled version of an analog signal, meaning it is measured at discrete time intervals. The process of converting an analog signal to a digital representation is called analog-to-digital conversion, ADC. When an analog signal is converted to a digital signal, it is quantized, meaning it is mapped to the nearest digital value. The number of possible discrete values that a digital signal can take is determined by the number of bits used in its representation. For example, an 8-bit digital signal can have 256, 2 to the power of 8, discrete values, while a 16-bit digital signal can have 65, 536, 2 to the power of 16, discrete values, and so on. Digital signals are used in various electronic devices and communication systems because they are easier to process, store, and transmit compared to analog signals, which are more susceptible to noise and interference. However, when converting from analog to digital and back, there is a loss of information due to quantization, which is known as quantization error. This loss of precision is known as the digitization error. To mitigate this, higher bit depths are often used for more accurate representation and to minimize the digitization error.